6.1 Composite Functions. So find a composite function and domain. Given two functions f and g, the composite function denoted by f composed with g is defined by f composed with g of x is the same thing or equals to f of g of x. The domain of f composed with g is the set of all real numbers x in the domain of g such that g of x is in the domain of f. To form a composite, you're going to put the second letter, whatever that function is, into the first letter function for every x and solve. Domain of a composite, you find the domain of the function you inputted, which is the second letter function, and then you find the domain of the composite. So we're going to practice with finding domain in example 2. Example 1, let's find our composites. So suppose that f of x equals 2x squared minus 3 and g of x equals 4x. Find f composed with g of 1. So let's just take this piece by piece. We have our f of x. So f of x equals 2x squared minus 3. And then we have our g of x, which is 4x. So f composed with g of 1, let's just pretend that 1's not there for a second. It's telling me to take the second function and put it into the first. So what that means is I'm going to take my second function and plug it into the first function where there's an x. So there's an x right here. I'm going to plug it in. So we have 2x squared minus 3. And the x we're plugging in is 4x. Now we do have this 1 right here. That 1 just means plug it in as x after you form the composite. So we now just formed the composite. Now we need to plug in 1 into here. So let's do that. We have 2 times 4 blank squared minus 3, and the blank we're plugging in is 1. And now all we have to do is simplify. So we have 2 times 4 squared minus 3. So 4 squared is 16, and 16 times 2 is 32. And 32 minus 3 is 29. So our final answer is f composed with g of 1 equals 29. We have to put that notation back in because it lets the reader know we took the composite, then we plugged in 1. Alright, part B. So part B, we're just going to do the opposite with the same number. I highly suggest that if you're like, okay, alright, I got this, pause it and see if you could do part B. Even if you can't, just try to do part B. Alright, I hope you really tried it. It's okay if you didn't. It's like, oh nope, I need to see this a lot more. That's okay. But I encourage you to do it, because if you're wrong, you're wrong. That's the only way you're going to be correct, is you just have to get it wrong. That's okay. Alright, so we have our g function, which is 4x. We have our f function, which is 2x squared minus 3. Now we're always going to plug the second one into the first one. So the second function goes into the first one wherever you see an x. So we have 4x, in this case x is 2x squared minus 3. Now we have a number on the outside. So since we have a number on the outside, we have to plug it in for the x that we have. So we have 4 times 2 blank squared minus 3, and the blank we're plugging in is 1. So let's simplify this. We have 4 on the outside, 1 squared is 1, and 1 times 2 is 2, all minus 3. So 4 times negative 1, we get g composed with f of 1 equals negative 4. So if we have that number on the outside that I circled in red, we have to plug in that number. But what if we don't have a number? Or what if we're just given x? Or what if we're not giving anything? That's fine. Don't plug anything in. If you're not given a number, don't plug it in. So you know how we were given 1? That's why we plugged it in. So for part C, you see how it has the x here? That means we form the composite and simplify. We don't plug anything in after that. Okay, so don't plug in anything. Just form the composite and simplify. I want you to go ahead and really try. Pause the video and try to do number C, or letter C. Okay, I hope you tried. I really hope you did. So we have our two functions, g. So we have g of x, that equals 4x. And since we have another g, I'm actually going to switch up the colors so I don't get confused. So the rules don't change. We're still going to plug the second one into the first one. So the second one gets plugged into the first one. So we have 4 blank, and the blank we're plugging in is 4x. Since we have an x here, we leave it as x. We don't plug anything back in. We simplify. So we have g composed with g of x equals 16x. You could also write g composed with g equals 16x. When you don't plug any number in, you can write it this way. Both are correct. Alrighty, part D, we have f composed with f of x. So let's go ahead and rewrite our f. So we have our f of x. It represents 2x squared minus 3. And since we're doing it again, I'm going to change up the colors. So we're going to plug the second one into the first one. It is always, always second one into first one. So our second one, we're going to plug it into our first one wherever we see an x. So we have 2x squared minus 3, and the x we're plugging in is 2x squared minus 3. Now we simplify. So we simplify, we have 2, and we have 2x squared minus 3, 2x squared minus 3, all minus 3, so we have to FOIL. I'm not going to show you how to FOIL, you know how to FOIL. So after you FOIL, we have 2 times 4x to the 4th minus 12x squared plus 9, all minus 3. We're going to distribute 2. And when we do, we have 8x squared minus 8x to the 4th minus 24x squared plus 18, all minus 3. Let's simplify one last time. So we have f composed with f equals 8x to the 4th minus 24x squared plus 15. Alright, let's do some more practicing with composites. Alright, so I'm going to do A and I want you to do B. So let's do A together. We have our two functions, f, which represents 9x, and then 9x plus 5. I forgot that part. And then we have g, which represents x squared. So for our first one, we're plugging g into f. So g into f. See how there's no x here? That means we don't mess with anything. We just form the composite and simplify. So let's form the composite and simplify. We have 9 blank plus 5. The blank we're plugging in is x squared. So we simplify. We distribute, so we have f composed with g equals 9x squared plus 5. That's it. That's all we had to do. There's nothing more we need to do there. It is simplified. So pause this. Try B. Alright, I hope you tried B. So let's go ahead and do this together. So we have our first function, which is g, so that's x squared. And then since it's the same one, I'm going to write it in a different color. So it's always second into first. So second into first. So our first one, we have blank squared, and in the blank, we're plugging in x squared. So x squared squared, that's x to the 4th. So g composed with g equals x to the 4th. We multiply. 2 times 2 is 4. Let's do composites with fractions, and then we're going to find our domain. If you don't have fractions, you don't need to find the domain, because your domain doesn't exclude anything, because there's no fractions and no radicals. So your domain is always going to be all real numbers, for example, 1 and 2. All right, let's find the composite and state the domain. So we have our two functions, f and g. So our first one, we have f of x, which is 2 over x minus 7. And then we have g of x, which is 5 over x. So we're plugging always the second one into the first one. So the second one into the first one wherever there's an x. So we only have one x, we only plug it in once. So let's do that. We have 2 over blank minus 7, and the blank we're plugging in is 5 over x. So we need to simplify this. I'm going to multiply everything by the denominator. So the denominator is x. So I'm going to multiply everything by x over 1, or just x. What that does is it cancels out the variable. So what we're left with is 2x over 5 minus 7x. And we cannot simplify there, so that is f composed with g. Now we need to find the domain. So to find the domain, there's two steps. Our first step is your first step is to find the domain of the function you plugged in. So for part A, we plugged in function g. So we need to find the domain of function g. So since that's a fraction, the bottom can't be 0. So we say bottom can't be 0. That's it. We can't solve it. X can't be 0. Then our second step is to find the domain of the composite. So our composite was f composed with g, and that was 2x over 5 minus 7x. When it's a fraction, we only care if there's a radical. There's no radical, and we only care about the bottom. So bottom cannot be 0. So we add 7x, and then divide by 7. So we have x cannot be 5 over 7. So now to find our whole domain, we just mush it together in one. So our domain, we have x such that x cannot be 0, and x cannot be 5 over 7. So that's our domain in set notation. Interval notation. So interval, I like to make pictures to kind of make sense of what we're doing. So I draw the x number line, and we have x cannot be 0. And then we have x cannot be 5 over 7. So coming from here, that's negative infinity to 0. The stopping point always means union. Then we pick up again from 0 to 5 over 7. We have a stopping point, that means union. And then 5 over 7 to infinity. That would be our interval notation. All right, let's do part B. F composed with F. Or I like to say FOF. You have FOF, FOG, GOF, and GOG. That if you just say that, I know what you're talking about. Because F composed with F, that's lengthy to say. All right, let's do part B. So part B is FOF, or F composed with F. And the F, our F function, is 2 over x minus 7. And then our other f function, since we have to write it twice, I'm going to write it in a different color. It's the same thing, 2 over x minus 7. It's always second into first. So second into first wherever there's an x. There's only one x, so I only have to plug it in once. So we have 2 over blank minus 7, and the blank we're plugging in is 2 over x minus 7. So I'm going to multiply everything by that denominator of x minus 7. So x minus 7, x minus 7, x minus 7. What that does is it cancels out that crazy denominator. So I'm going to distribute. We have 2x minus 14. On the bottom we have 2. And then I'm going to distribute negative 7. So that's negative 7x plus 49. Let's combine like terms. So we have 2x minus 14 over negative 7x plus 52. You could also have 52 minus 7x. It's all the same thing. Sorry, 51. 51, not 52, it's 51. So that is f composed with f. Now we need to find our domain. So remember, there's 2 steps. We need to find the domain of the second function. That's the function we put in. So the function we put in was f. So we do bottom cannot be 0, so x cannot be 7. Then we find the domain of the composite. So the domain of the composite, so our composite was f composed with f equals 2x minus 14 over negative 7x plus 51. So we said bottom cannot be 0. So we have negative 7x plus 51 cannot be 0. We're going to subtract 51 over. Actually, I would add 7x here to make it positive. So we have 51 cannot be 7x. Divide by 7. We have 51 over 7 cannot be x. Alright, let's go ahead and put it in set notation. So set notation would be x such that x cannot be 7. And then x cannot be 51 over 7. In interval notation, let's draw a picture. So in interval notation, we have 2 things x cannot be. X cannot be 7, and x cannot be 51 over 7. So our first one, we have negative infinity to 7. The stopping point means union. And then we have 7 to 51 over 7. The stopping point means union. And then we have 51 over 7 to infinity.